Welcome, everybody. Thanks for taking the time out of your day to attend this talk. As usual, I've got a lot of information that we want to try to fit into a time frame of about an hour. That should work. Hopefully I don't go over, but if I do, it won't be by much, and I fully understand if you need to drop off. So with that, well, for better or for worse, most of you know who I am, so we can skip my profile and just dive right into today's agenda, where we'll be talking. If you read the abstract for the talk, you know that, and from the name itself, Learning Entity Framework. So this is an entry-level talk. I'm assuming no prior knowledge of Entity Framework, and we're even going to talk about the basics of ORM first before we actually dive into Entity Framework. So we're going to discuss Object Relational Mapping. If you know what that is, great. If you don't worry, we'll demystify that. And then we'll have a look at Entity Framework, which is Microsoft's ORM offering. It's their data access layer. And we'll examine the various approaches that you can take when building applications with Entity Framework. These are methodologies known as database first, model first, or code first. And there's actually a fourth variant that we'll talk about. But these are all design time methodologies in the sense that regardless of which approach you take, at runtime it's the same experience working with Entity Framework in terms of querying and updating, where your choices are to use either Entity SQL or Link to Entities. Now, Entity SQL, we're only going to touch on just as a matter of curiosity. It was actually the original native language when Entity Framework was being developed. But Link was being developed at the same time as Entity Framework, and you were no one if you didn't have a Link provider. So, of course, a link provider for Entity Framework was released at the same time, and that's called Link to Entities, and that has turned out actually to be the preferred and primary and best way to work with Entity Framework. So it's all going to be all about Link to Entities, and you'll just see a little bit of Entity SQL. So Object Relational Mapping, ORM, is a very simple concept, assuming that you're dealing with an object-oriented application that you're building. That's the O. And assuming you're dealing with a relational data store, not a NoSQL store, as is becoming increasingly popular, but a relational store, such as SQL Server. That's the R, that's your database. In one way or another, you need to map those two in order to get your application to work, right? You need to get data from the database, your relational database, into your objects, and back again when changes need to be pushed back to the database. And so it's the mapping layer, that's the M, that is pushing, or let's say shuffling data back and forth between the relational database and the object-oriented application. Now, you could be doing this by hand, in which case it's a manual ORM process where you just run a query and get back a reader and loop through that reader one row at a time and one column at a time, shove those into the properties of your object instances. And if you're doing it that way, well, then that's your ORM. That's how you're mapping your objects in your relational store. But, of course, in most cases, when people use the term ORM, they're referring to one of these robust frameworks that is designed to take that grunt work out of the process and do all that lifting for you, the boring part, so you can stay focused on the creative aspects of your application. And they're talking about something like Entity Framework or NHibernate, and there are others, but we'll be talking about Entity Framework, of course, today. But in general ORM terms, you're really talking, like I said, about mapping objects to the relational database, where you can loosely think of things in terms of being one-to-one, where each table will have a class. So if I have a customer table and an order table, it probably follows that I'll have a customer class and an order class in my application. And for all the columns that are defined in the tables in the database, it's very likely I'll have same or similarly named properties in my classes. And where there are relationships in the database, I'll have collections. And where I have stored procedures that might have custom business logic in them, I might think of them as functions or methods, right, that I can just call in my application. But that's a very simplistic view of the world. In reality, things are not always one-to-one, and you have this, very often, you have this so-called impedance mismatch, which is just a fancy way of saying things are not always one-to-one. Where it's possible that the column names will be different than the property names, where you might not have a one-to-one correspondence between tables and classes. You might have multiple tables for one class or vice versa. I'll show some examples of that coming up, so I'm not going to spend the time here. But the point is that's really where Entity Framework shines because it can handle this impedance mismatch, and it can let you map things that are not one-to-one. So a lot of people are turned off to certain aspects of Entity Framework and don't understand that the Entity Framework gives you a lot of choices. So you really shouldn't reject it out of hand. I mean, at a minimum, it will do certain things for you, like manage connections, commands, and readers. These are things that before Entity Framework with ADO.NET, you would have to do those things yourself. Similarly, you would have to do the results and shove them into objects, right? By looping through your reader and doing that kind of manual ORM that I was describing, and copying properties into, copying column values into properties. You would also have to track objects for changes. So EF will do all those things for you, and I think you'd be hard-pressed for an argument as to when you would want to take on those burdens yourself. I mean, these are things that Entity Framework is really good at. If performance is what you're concerned at to this point, then don't consider Entity Framework and stick with conventional ADO.NET. But to this point, there's really not much overhead that Entity Framework is going to add, and it's going to do all of these things for you. So you'll never touch a connection or a command or a reader. You're going to get back objects that are ready to use, and by ready to use, I mean they're ready to bind to the UI, and they will be tracked for changes. And when it comes time to update, the objects that have been tracked for inserts, updates, and deletes will get pushed back to the database. And all that grunt work is taken out of the process, and EF will do those things. Now, in addition, EF can also do other things that you may or may not want to opt in on. So one of those is that it will actually design your database if you want it to, something that database purists don't like, and the audience at SQL Saturday this Saturday is, DBA-like people, and people like myself, even though I'm an application developer, I do believe that you should be designing your database by hand explicitly and not having it kind of like reverse engineered from some sort of conceptual model. But if you want to, and it can be very handy for very quick proof of concepts or one-offs or quick demos, you can design your conceptual model and either in code, which is a code-only approach, or with a visual model, which is a model-first approach, and Entity Framework will reverse engineer that model and design the database. It'll generate the DDL. Of course, you can query, I said, with linked entities, and it'll generate select statements, but many folks are critical of select statements that get generated dynamically by Entity Framework, and people claiming that they can write better select statements themselves. Well, if you can, great, but in most cases, and this is one area where Entity Framework has gotten better over the years, in most cases, Entity Framework will generate select statements as well as, if not better than, one you might write yourself. I don't mean in terms of neatness, and that neatness doesn't matter because it's not something that has to be maintained. It's code that gets generated, executed, and discarded. But in terms of performance. But if you don't like that, either across the board, you don't want to permit direct select statements, or you're in an environment where the DBA has locked down the tables where you can't even run a select if you wanted to, and you can only query through stored procedures, you can write your own stored procedures, query it your own way, and you don't have to let Entity Framework generate the select statement for you. And the same is true on updates. In most cases, for production applications, you probably would not want Entity Framework to generate the insert, update, and delete statements to push changes back to the database, because it's more likely that you'll have stored procedures in charge of performing updates that will have additional business logic and validation inside of them, and we'll see demos of that. But, again, if you don't create those stored procedures, Entity Framework will go ahead and generate the DML to do the updates, but you don't have to go with those. You can be in control of the DML. And finally, the C# classes, which represent your conceptual objects, right? You can have, you might want to write those yourself, or you can have Entity Framework generate them for you. And so really, you have to really look at Entity Framework as a kind of a set of core functionality that it provides that you just kind of embrace and let it do a lot of the heavy lifting that you used to do manually, and then the rest as just kind of a buffet where it's pick and choose what you want. And it's not even across the board. You can say for certain queries, it's okay to let Entity Framework generate dynamic select statements, but for other types of queries, no, I want these specific stored procedures to be called. So now we're diving into Entity Framework, which is by now, and for a number of years by now, Microsoft's officially recommended technology for building a data access layer for any .NET application. in today's world of the web, and everyone's thinking rich web client applications with Angular and so on, they're still making API calls, and those API calls are running on the back end. And on the back end, you may very well want to embrace Entity Framework. It got up to a rough start, as you can see on this slide. Version 1, it got a lot of criticism, and it was just missing a lot of features. It just wasn't ready yet. It was prematurely released. They skipped a few version numbers there, but they did a really good job addressing the shortcomings, so we'll overlook that. And by now we're up to EF6, which is very, very full-featured. I'm not going to spend time talking about the shortcomings, since most of the significant ones have all been addressed by now. So now let's talk about the entity data model, the EDM, which lies at the heart of the entity framework. And it has 3 parts. There's the conceptual schema. Those are your objects. That's the O and ORM, right? That's how you view things in your application in terms of objects, properties, classes, and so on. And then there's the storage schema, which is how things are laid out physically in the database. And then there's the mapping schema. And again, for simple scenarios where things are one-to-one, the conceptual schema and the storage schema will look very much the same, and the mapping schema will just map things one-to-one. I mentioned about that there are multiple ways that you can go around designing the entity data model, and we'll have a closer look at those shortly. And I also mentioned that there's 2 approaches you can take with querying, entity SQL and link to entities. In fact, for sure, link to entities, like I said, is the primary and most common and popular way to work with Entity Framework. When you work with Entity SQL, there's actually 2 ways that you can go about it. One is, as the second bullet point says, you can use object services, which means, but very similar to using link. Instead of expressing your query using link syntax, you express it using eSQL syntax, but in either case, you get back these objects that are tracked by the context, and you can bind to them, and when changes are made, Entity Framework can push those changes back to the database, regardless of whether you used eSQL or link to query. But in the case of eSQL, there's another option, a very lightweight option that avoids objects altogether, using the entity client, and you'll see a demo of that where you'll see the very familiar primitive ADO.NET objects, like instead of a SQL connection, SQL command, SQL reader, and so on, you'll see that there's an entity connection, entity client, and entity reader object that work very similarly when you just want to stream results back and you don't need to instantiate objects. So that's the entity data model. Your application interacts with the entity data model, which in turn interacts with the database. So at design time, like I mentioned, you have these 3 parts to the entity data model, and you're concerned with all 3 parts. But at runtime, your application is concerned only with the conceptual model. And because of the ability to map things that are not one-to-one, as I was describing earlier, you can take advantage of that and do some very cool things. Right? So in the conceptual schema, that's where your entity classes, properties, and functions exist. And in the storage schema, you've got things laid out in database terms. But that means you could do something like split an entity, where logically it makes sense to have a single customer entity, but physically, for whatever reason, in the database, it makes sense to partition that information. And you can have Entity Framework I'll do that join for you automatically on the retrieval, and you have a single customer object that's tracked, and you will modify properties, some of which are backed by one table, others of which are backed by the other table, and on update Entity Framework will break that out again for you. And you can do the reverse, which is kind of similar, but in the opposite direction, where you might have a very wide customer row with many columns that in many scenarios you don't need to retrieve all those columns. There's a certain set of kind of core columns that you need most often. So you'll define those in your customer class, and you'll have a customer extension class, if you will, or some other better name, that has the less frequently used properties, and that way you can query for just the ones you need, or all of them, but on the back end it's all a single table. You can implement inheritance, and there's actually two ways to do that. So you might have a single person table in the database, each row of which is a different type of person, and there's a column in there known as the discriminator column that will identify on a row-by-row basis what type of person row is being stored in the database. But of course, conceptually, you think of one as being a customer object, one as being an employee object that both inherit from a base person class, and you can model that and very easily. And this is one of two ways to do it, using table per hierarchy, where you can imagine a lot of nulls being present in the person table, because from one row to the next, depending on the type of row, not every column will be applicable. But you can instead implement inheritance by going table per type, where you have a one-to-one, if you will, between, where you store in the database physically shared person columns in the person table and customer-specific columns in the customer table, employee-specific columns in the employee table, and then you just map those one-to-one and you get your inheritance that way. And finally, I think this is the last example, you can have a many-to-many implementation where in the database, of course, you can really only model a one-to-many relationship. If you want a many-to-many relationship, you need a third table that serves as a junction table. And that's just the way databases are. Conceptually, though, we just want to concern ourselves with a customer object and an employee object, and in object-oriented terms, it's very natural to think of a customer table having an employee's property that is a collection of employee objects, and vice versa. Each employee object would have a customer's property that's a collection of customer objects, and there's your many-to-many. So you don't want to concern yourself with that junction table in the middle, and Entity Framework can abstract that away for you and manage that for you. So now that we understand what the Entity Framework is, it's time to start working with it, and like I said, your application doesn't connect directly to the database. So it's talking through the entity data model using Entity Framework and to get to the database. So your application actually doesn't have a database connection string. It has an entity connection string, and it looks like this, and it looks a little scary, but it's really not, because if you break it down, you'll see it's not that difficult to understand what's going on. You see this is a semicolon delimited string. The metadata, the provider and the provider connection string, and the metadata itself is made up of three parts in a pipe delimited string. So there's a pointer to the conceptual schema, the storage schema, and the mapping schema, which are the three parts of the EDM. And they need to be available at runtime. Now, what's with that funky res : / syntax? That just means that these are embedded as resources in the executable, something you would probably actually not want to do in production. This is just the default. In production, you'll probably want to store these as external XML files. It would give you the ability to tweak the mapping layer at runtime without redeploying the application. Take, for example, a scenario where someone comes along and modifies a column in a table, and now you've broken the application, but you can, if that's the only change they made, if it's not a very disruptive change, you can go into the mapping layer and say, well, the property that used to be mapped to the old name is now mapped to this new name, and not have to redeploy the application. So that's the metadata. And the provider, because Entity Framework is designed not to be tied to SQL Server, but to work with any back-end relational database system that has an Entity Framework provider available, that's your, SQL Server, standard SQL Server client, and the provider connection string is unique to the provider, and that's where you see the familiar SQL Server connection string. Let's just quickly push through the methodologies. With database, first you design the database. It'll generate the EDM, and from there it'll generate C#. Then you can, of course, tweak the EDM when things are not one-to-one, as you're about to see. With model first, you design the EDM yourself, and it generates the C# code and will reverse engineer the database. If you write your C# code first, it will reverse engineer the database, and it will also reverse engineer the EDM. The way you map things that are not one-to-one is by using a kind of an awkward combination of annotations and a Fluent API that's available that now I'm not sure I'll have time to show you because it's at the end, but database purists definitely are not a fan. And then there's this kind of weird variant where you can design the database by hand and also write the C# code by hand, because you just don't want a clunky visual graphical model for whatever reason. So that's also an option. But I think it's time to start actually writing some code now. Just going to let this come up and we'll get started. Well, what we're about to do is demonstrate database first. So I'm going to actually create the database. I have a script ready to go that creates the database. I will first run the script, and then I'll explain what it does so that we can see how things are going to work with our entity data model. All right. What we now have is a database called SampleDB, table with an ID, a handful of columns, and these two created and updated add values. We have an order header table with its own primary key, an order header ID that's also an int identity, a foreign key to the customer table, the customer that the order belongs to, a ship via this order status as a tiny int, so it's just this value 1, 2, or 3, having those meanings. And again, this kind of pair of what I'll call auditing columns. So these are just date-time data types that track when each row is created or modified in the table. Then we have that relationship between customer and order header, and now I have an employee table, which again has a pair of those auditing columns, and it has properties that are unique to an employee. And because there's a many-to-many relationship between customers and employees, I have this junction table with a customer ID and an employee ID column and the two one-to-one join relationships coming out of that table to give us the many-to-many. That's it for the tables. Now I've got a few stored procedures. Yes, Entity Framework can generate a select for me, but what if I want a stored procedure that's going to do it? Well, I can create a stored procedure that takes a parameter, and in this case it returns just one customer row based on that customer ID, but the shape of the data returned by the stored procedure matches. These are all the columns, like a select star, right? So the same shape of data that would come back if Entity Framework generated a select statement. Here's another one that doesn't take any parameters, and it's the same shape, but there's no where clause, so it returns all the customers. And you can imagine you would have others that take different parameters and return customers based on criteria that you code yourself in T-SQL rather than Entity Framework generating the query. Now, here's another one that's similar, but it's implemented as a table-valued function, so there's a schema definition at the top that shows all the columns coming back, but again, it is the same shape as the customer table, and it's doing the insert and returning the row back out, but it's inserting into what's being returned, so it's really effectively the same thing like a stored procedure, but it's a table-valued function. You can have your own T-SQL logic in here. Now I've got some update stored procedures. So when I want to insert a customer, let's say I don't want to accept from the client the values of these auditing columns because those are I want to be in control of those on the server. I only want to accept, some of, these others. So that would mean that in my insert stored procedure, I'm only allowing the first name, last name, and balance. Internally, I'm also setting the created at to be the date on the server clock. And then notice after the insert, what I'm doing is I'm selecting back out the two pieces of information that the client did not know about this customer entity before it requested the insert. It didn't know what the ID was going to be because it's an int identity, and it certainly didn't know what the created at was going to be because it's the created at value based on the server clock. But as a result, because I get these two properties come back out of the stored procedure, Entity Framework is going to be able to refresh the instance of the entity that's in memory without having to reload the entire entity to get it in sync with the version that's now in the database. For update customer, again, now in this case I've got optimistic concurrency in place so that there's an expectation that before you update the customer you had to have previously selected it so that you have the original updated at value that you retained from when you selected. And now when you update it, it needs to either match or it needs to be null, and it still needs to be null, meaning no other user has come along and modified, otherwise we raise an error. If there's no error, we'll again return back out the one piece of information, which is the new updated at value based, again, on the server clock, so that the client-side instance of the entity can be refreshed. Delete, I've got it really simple because, I don't know, I just didn't add anything, but I certainly could. It's just a stored procedure that takes a parameter and does a delete. No different than if Entity Framework generated the delete. Now, all those stored procedures to this point fall into the category of what you would call a CRUD stored procedure. Their purpose in life is to wrap themselves around a table and select, insert, update, or delete against that table. But then you'll have these kind of general purpose stored procedures, things that do business logic, like get positive balanced customers, where there's a group by and I'm doing an aggregate count, and the shape of the data that I'm returning does not resemble any existing table in the database, but it's still kind of a schema for the result set coming out of the stored procedure as having a customer name where I can cat first and last, and an order count, which is an integer. Here's another general purpose stored procedure that also returns data, but not in the form of a result set. It returns it in the form of an output parameter. So you might have lots of these different types of stored procedures, and they can all work with Entity Framework. And finally, at the bottom, just inserting some dummy data. That's all that's happening there. So now with that in place, I'm going to go ahead and create an entity data model. And then we'll switch over to an application that I have already running, or pre-built, that has a code already written. So let me flip over to my blank instance of Visual Studio. I'm going to create a new project. Keep it simple. Keeping it simple, I'll just make it a console app. Save that out. And now I'm going to right-click and say Add New Item. I'm going to go to Data, and it's right there at the top. ADO is on the entity data model, and I'm going to name it the same as the database. Now, best practice in production, you would create your entity data model in its own class library project and then reference that DLL from your main project. If I was going code first, I would choose this. Model first, I would start with an empty model and then manually build my model and generate the DDL from that. But no, I'm going database first. So it's generating a model from an existing database. I'll connect to the database that we just created. And you'll see right away that funky connection string, but it shouldn't scare you anymore at this point because you understand what it is. You see the metadata, and you see the provider and the provider connection string right in there. And you would take the same care you would take with any connection string in terms of where you persist this. For now, it's just going to go in the config file, and I'll click Next. I could use an earlier version of Entity Framework if I needed for backward compatibility, but instead I'm going to use the version that ships out of the box. There's almost always a more current version available on NuGet. So this is 6.1.1, I believe, which is part of Visual Studio 2013 Update 3. I want to bring in all my tables into the model. There's the tables that we created in the database. If I had views, I could bring them into. I do want to bring in all my stored procedures, but for reasons that I'll explain in a moment, I'm going to unselect the three CUD, C-U-D, stored procedures, the create, update, and delete, the ones that are used for the DML. And I'll explain why later. We'll bring those in again in a later step. For now, I'm leaving them out and pulling everything else in. I'll go ahead and click Finish. And that takes us to the designer for our entity data model. Oh, you see in the toolbar on the bottom, it's adding Entity Framework 6.1.1 to the project. So that came shipped out of the box. If there's time for the code first demo, you'll see you can just use NuGet and pull down the latest, which is 6.1.3, I believe. But if I added another EDM after this, it would go much faster because it had to actually pull in all the DLLs. You see it's added the references here on the right. And here we are. We're looking at our entity data model. And the first stark observation that you might make is, wait a second, we have 4 tables in the database. but I only see 3 items on here. And the reason for that is because you are only looking at the conceptual model. And the designer picked up on the many-to-many relationship because there are only those 2 columns. If you look closely between customer and employee, you see asterisk to asterisk means many-to-many, as opposed to customer to order header, where you see one-to-many. And so you're only looking at the conceptual model. How do you look at the entire EDM, all 3 parts? Well, for that you go to the model browser, and here we've got a tree view on the right, and here I'm looking at, again, the conceptual model, so it's the same 3 entity types, but if I expand sampledb model.store, that's the storage schema, you'll see things in database terms, and indeed you see all 4 tables. And in fact, this entire EDMX file is just one large XML file. In the early days of the entity framework, it used to be necessary to go into the XML quite often to tweak things. That's no longer necessary, but it can still be very educational to see what it looks like, to understand what's happening. So I'm going to open it up with the XML editor. And collapse things down so we see them at a high level. And you really don't need to pay attention to this designer section at the bottom. That's just for Visual Studio to remember how your diagram looks at design time. At runtime is what matters. It's the EDM, the 3 parts, like I said. Here's the storage model. It comes first. Unfortunately, they're using entity type. It should really be table type because these are tables, not conceptual entities. You see when I collapse it down, you'll see all 4 tables are defined in there, as well as the relationships and so on. If I expand out the conceptual model, that's where you're going to see true entities like customer, employee, and order header. And you'll also see these things called complex types. They are similar to entities in the sense that they define the schema of an object, like a class definition, but it's based upon the results the entity framework figured out. If I call this user-defined function, I'm going to get back a result that looks like this. Also, the same is true of like select customer, right? Those two store procedures that I created, these are complex types. All right, and then when I call get positive balance customers, I get back that schema that has only 2 columns, the customer name and the order count. You can see that it has basically created complex types that map to the schemas of the result sets coming back from stored procedures. So, it's very enlightening to look at the XML view, but really once you've done that, you'll probably never want to go back again and just keep looking at the graphical designer. They added some really nice things in later versions of Entity Framework, like in EF6, the ability, this is a very simple model, there's only 3 entities. It can get very large and very complex very quickly. A nice thing that you can do is create multiple diagrams and have, such sets of logically grouped entities appearing on each diagram, and you can color code them to aid as well. So let's say I wanted to say that order-related entities are green. It's really easy to do, as you can see. But now it's time to look at what else got generated for us. So we saw the entity data model got generated. Things are not exactly one-to-one, that it has already factored out the many-to-many junction table there. I want to first show you the generated code. So this is C# code that got generated. First is the context class. It inherits from this class called dbContext. And you can see that it has these public properties that are pluralized versions of our table names. So we had customer, employee, and order header. These are pluralized versions of those names, which is a DB set of those entity types, and it represents those classes. And when I want to query for customers, all I need to do is create an instance of this context object and issue a link query directly against customers, and it will dynamically generate a select statement for me. If I look at some of the other generated C# code, here are my POCO classes, just plain old C# classes. You're not forced to inherit from a particular base class, as was the case with a very early version of Entity Framework. Furthermore, because it's a partial class, you can extend this class by creating another CS file that extends the customer class with the partial keyword and have that partial class inherit from some base class. You can add your own methods. You can add your own extension functions, whatever you want. You will just don't want to modify this code because, like the comments on top indicate, it's going to get, everything will get overwritten when the next time it regenerates and when there's a change to the schema. Right. So now flipping on back to the EDM, if you look at what else is in the entity data model, I've got these function imports. Right. These are functions. These are store procedures that were imported as functions. You'll notice the three that I excluded deliberately, three of them, the insert, update, and delete. Why did I do that? I said I would explain it. Well, I will never be calling those store procedures directly. The way the entity framework works is that it just tracks the changes to all your objects. And at any point in time when you just say save changes on the context, it will update all the entities that have changed. And it's up to you to map insert, update, and delete store procedures to each of these entities. If you don't map those store procedures to these entities, then calling save changes will generate dynamic SQL for the DML. But if you do map stored procedures, then calling save changes will call those stored procedures. But you're still never going to call the stored procedures. You're just going to call save changes. So if you look at select customer and select customers, if I query directly against customers, like I said a moment ago, these entity sets, the pluralized version. So if I query against customers, it's going to generate dynamic SQL automatically. It's going to generate a select statement that I may or may not like. But if I query against select customer or select customers, it will call the store procedure instead. Now here's what's interesting. It wasn't smart enough to realize that the shape of the objects coming back from these two store procedures is in fact the customer object. You saw earlier it created these complex types. We don't need these three. All three of these are exactly the same as a customer, and we don't want them to be complex types because a complex type, the context will not track changes to them. So I have to tell the entity framework I know a little better than you and go into the dialog. It doesn't return this complex type. It actually returns a true customer entity, and the burden is on me to make sure that this stored procedure returns a result that is exactly like the customer table. But now I can say it's an entity that gets tracked for changes as opposed to a complex type that doesn't. And the same is true of this guy, this other stored procedure. And the same is true of this user-defined function. I know that they all return customer objects. I don't need those complex types now, and I can delete them, and I should delete them from my entity data model. Okay, and now let's look at some table mappings. If I right-click on the customer entity and I say table mapping, so we're looking now at table mappings where you can see things are one-to-one, but I could add another table. Right? It doesn't just have to be the one customer table. It could be another table, like we saw in the slides, and I could have two tables joined together into a single conceptual entity. Or vice versa. I could have a single table, but add a condition whereby only certain rows in that table are really customers. And Entity Framework will automatically filter on that when I retrieve customers and automatically set that value appropriately when I save customers. If I flip on over to the order header entity, it's a similar thing, but I want to demonstrate that we have the ability to use enums. So that going back to our database, where in the order header table, we have this tiny int, 1 is pending, 2 is shipped, and 3 is canceled. I want to refer to those as enums in my C# code, in my application, of course. So I'm going to create an order status type enum right here. Now, it's possible I have an external DLL where the enum is already defined, and I can just reference that with this checkbox on the bottom, but that's not the case. I need code generated. I'm going to call it order status type. The underlying type is a byte because it's just a tiny int, and it's shipped, or whatever they were, canceled, and pending, what have you. No, let's actually stick to the correct ones. Pending, shipped, and canceled. I could do this, but it's not really necessary. as you know, if you're familiar with enums. So pending is 1, shipped is 2, and canceled is 3. I'll go ahead and click OK, and you'll see that I have a new order status type. If I actually look at my code, that this got generated. There we go. See this code that got generated, order status I've got generated for me, pending, and now in my table mapping, the property of specifically the order status column or the order status property. I can say it's not a byte, but if I scroll down, you can see, by the way, they added support for all the geospatial stuff, which is nice, but all the way at the bottom you can see the enum that I defined, order status type, and now it's being treated as an enum. There's one last part, otherwise, in order to kind of bring it all together, and that is those stored procedure mappings for the updates. So now let's say the database has changed and I need to update the model to reflect the change. You go to Update Model from Database, and on the Add tab, there's kind of like this diff where the designer compares what's in the database to what you have in the storage model. And we have all the tables, we have all the views, so those are empty, but we left these 3 out, and so the diff is showing those as 3 stored procedures that we've still not yet pulled into the model. I'm going to pull them in now, but I'm going to uncheck this checkbox on the bottom. That's why I left them out before, because I don't need them as function imports. And in fact, I don't need complex types that might get generated by calling them either. It would be needless baggage in my EDM. It wouldn't break, but it wouldn't be necessary, and we want to keep things lean. So I'm just going to pull them in. This is a very poorly phrased checkbox. Import selected stored procedures and functions into the entity model. It's a poorly phrased because I really actually am importing them into the model, but I'm only importing them into the storage schema, not the conceptual schema of the model. So by clicking Finish Now, you'll see that if I go back to the model browser and I look at function imports, they don't show up. They still don't show up because I've not imported them into the conceptual model. I won't be calling them directly. Instead, however, I can go to the customer table and look at my stored procedure mappings. You can see that nothing is mapped yet because it's asking you to select a function. As long as it's asking you to select a function, that means it's going to generate the DML for you. But I can see here, I see all the stored procedures, even the ones just in the storage schema. So there's insert customer. Because I've named things consistently, I have very little work to do to map the parameters of the stored procedure with the properties of my entity. But remember those 2 values coming back? There's the new customer ID that's going to come back in that single row result set. I want to shove that value back into the customer ID of a newly inserted customer, and created at, which got set by my stored procedure, I want that shoved back into the created at property of my instance, and that's going to bring it into sync. My update stored procedure, it works very similarly. I'll call update customer. On the output, right, we have the new updated at, assuming there's no optimistic concurrency violation, and we want that shoved back into updated at. For delete, I just map the delete, and we're done. So I'm flipping on over to a project that already has code written that uses the exact same entity data model that we just built by hand. Everything works exactly the same. I'm going to go ahead and give it a run through a bunch of demos for about the next 10 to 15 minutes, and that will be the end of the session. Okay, so let's give it a run. I have breakpoints set up already. So we should just be able to hit 5. And let's start with direct SQL. I'll hit my breakpoint. Hopefully everyone can see the code clearly. I'm going to step now, and this lets me watch what's going on behind the scenes by calling console.write whenever Entity Framework generates T-SQL. So I'll be able to look in the output window. Let's make sure we've got that up. Okay, let's clear it. Now, look at this link query. I'm querying from the entity set, the pluralized version. Remember what I said, that if you query directly against the entity set, it will generate a direct SQL statement. So keep your eye in the output window as I step over the next line of code and you'll see that actually nothing happened. And that's because this is standard link behavior. That's deferred execution. The query has been defined, but it hasn't been executed. I would need to kind of tap it on the shoulder, either by invoking toList, like I'm doing now, or by for-eaching my way through it. But now when I press F10 to step over this line of code, you will see, in fact, output just got generated to the debug window, and there's the select statement. So yeah, it went ahead and took my link query that is using C# syntax, or I'm filtering where the customer's last name doesn't start with the letter A, and at runtime it figured out that it should translate it into a where clause in T-SQL where not last name using the like operator and the wildcard symbol, right? But, clearly the filtering is taking place on the server, and when I let this run through and it tells me that I've got, 3 customers, only the 3 customers whose last names don't begin with the letter A came back from the server. If I run this next demo, which looks almost identical, if you look at this demo, it is virtually an identical link query to the one we had before. The only difference, okay, is instead of going against the customer's entity set, that pluralized name that's hanging right off of the context, which we know generates direct SQL, I'm calling the function import. You can see the double parens. That tells you that it's a function import. It's not an entity. It's a function import. Otherwise, it's the exact same where clause. And it's the exact same demo in every other respect. So when I step over, right, and let me clear the output window from the last demo, notice when I step over this line, which just defines the query, it still went ahead and executed the stored procedure. So what's going on here? I mean, what about deferred execution? Well, what happens is because stored procedures are not composable, this is just an inherent limitation. You can't say select from stored procedure where. You just can't do that. So what has happened is that this stored procedure executed, it returned all of its results, and now this is no longer a link to entities query, it's a link to objects query, and the deferred execution at this point is an in-memory filtering over everything that came back. So is that a good thing or a bad thing? And the answer is it's neither and both. Really, it depends on whether you're using the feature or abusing the feature. So if you're pulling back, obviously if you're pulling back millions of rows in your stored procedure and you only need 2 or 3, that's obviously a very bad thing and you would never want to do that. On the other hand, if your stored procedure is pulling back a reasonable set of rows and you're only filtering out then a few on the client, well then it's perfectly reasonable and there's nothing wrong with that. Just understand that that's what's happening. Understand what it is you want to do and what it is you're trying to do. But fortunately, there's a workaround for this, and that's using the table-valued function. So here, I've got a table-valued function on the server also called select customers. I prefixed it with UDF, if you recall. It's a user-defined function. So like a stored procedure, it runs on the server, but unlike a stored procedure, it is composable. You can say select star from user-defined table-valued function where, and if there's a where clause in the table-valued function, that will execute, and then if there's an outer where clause on the code that's selecting from it, then it'll execute as well on top of that. So this filtering now, as you can see by looking in the output window, nothing got executed. Only when I step over the toList, you'll see that it executed a select statement. This where clause got sent over to the server, but what's it selecting from? It's selecting from the table-valued function, which, if it had inside of itself its own where clause, would be the first level of filtering. Second level of filtering happening with the where clause, but all of the filtering happening on the server and only bringing back the rows that satisfy the filter. The next of these set of demos that kind of work the way you would expect. This is making a stored procedure call, right? We're calling that get positive balance customers stored procedure, and we're invoking toList on it. That calls a stored procedure and gives me a list. You can see I've got a bunch of these types. The get positive balance customers underscore result, that's the complex type. I've got customer Anna Anderson with an order count of 1, Lucas with an order count of 2, and Luke with an order count of 4. So there was aggregation performed in the stored procedure on the server, but now that I have the list on the client, I can aggregate over it again, like I'm doing with a link sum query over the memory resident result set. and getting the total dollar orders, which is total orders, which is 7, of course, 7, which is 1 plus 2 plus 4. Output parameter works very similarly. It's just that you do need to set up this object parameter object, which is a little weird, because it's an output parameter. So I'm getting the balance of this customer, ID 4, back in this balance parameter object, and the dot value property is the output parameter returned, which is minus 40. Updating data. Let's step. And here what I'm doing is I'm writing my query, and then I am intentionally wrapping it in parentheses and invoking toList on it, because my intent is to not query it multiple times. This way I can loop over customers as many times as I want. If I didn't do that, I might accidentally issue multiple queries every time I tapped on the customer object. So you've got to know what you're doing and what your intent is. So this you'll see in one shot. We'll run the code. Here's the select statement, but I've only selected customers. I haven't selected orders. And the customer count is 0. Better not be. And it isn't. Otherwise, I'd show an error. Now I get the first customer, and I want to know how many orders does that customer have. Well, look, I'm not issuing a query here. I'm just tapping on the count property of the order headers collection of that customer, and I would get back an order count of 4. How does it know there are 4 orders? Well, look, it generated another select statement to retrieve all the orders for this customer. That's lazy loading. Very nice feature. So it didn't need only needed the order headers once I requested the count on it. So now they've been loaded as well. And they won't get loaded again once they've been loaded once. So customer 3 has 4 orders, and now I'm going to go ahead and change the customer's first and last name, so I have one modified customer. I'll add a new order to that customer, so I've got a modified customer as well as a new order in the order header collection. Notice I'm able to use my enum, and now I'm calling save changes. We have 2 modified entities. For the customer entity has been modified, but we have stored procedures mapped, and so we expect stored procedures to get called for that. We don't have stored procedures mapped for the orders, so we'll expect to see DML get generated, and in fact, it's exactly what we see. You can see very clearly it went ahead and generated this insert statement into the order header table, and it even did my translation on the enum to be a 1. But when it came to updating the customer, it called my update customer stored procedure, and it passed in these parameters, including the original updated add. Right? So it works just the way you would expect it to, and it has called stored procedures where I've mapped them, and it has generated DML where I haven't mapped stored procedures. Last demo, or I'll keep going until there's no one left, which works for me as well. Many to many. So if I say I've got 3 customers and add them to the context, now the context is aware of 3 new customers. I'll define 3 new employees and add them to the context, and now the context is aware of 3 new employees. I can work in either direction. I can add employees to a customer, like I've just added 2 different employees to the same customer, and here I added 2 other employees to a different customer, or I can work in the other direction. To one employee, I can add 2 customers. Now I'm going to click Save Changes. Let me clear the output from before. I'm going to run Save Changes. I'm not going to go through all of this generated code, just enough for you to see what's happening. Well, I went ahead and inserted 1 employee with a direct insert statement, and a second one, and a third one. Then it inserted the first customer using a stored procedure, of course, because we have stored procedures mapped. And then, look what it did. It inserted into that junction table. My application doesn't even have any awareness of this table. I don't care about this table. I'm just adding many to many by using .add to add to a collection. And Entity Framework is tracking these IDs for me and updating or inserting the customer employee table as necessary to map employee 5 with customer 1 and customer 2 and so on, all the way down, which is really very, very nice. And then on retrieving, Okay, so let me kind of just clear out this window. When I go to the customer's collection on an employee, you'll see a query get generated. Oh, I cleared it out already. Okay, well, at least we got one in the other direction. Here I'm getting all of the employees belonging to a particular customer. You'll see that it is joining on that intermediate table automatically to get the related rows in a many-to-many relationship. I'm just going to show you this entity SQL example. It looks like SQL. It looks like T-SQL, but it's not. This is not a table. This is a conceptual entity set. This is just like doing a link query against the customer's entity set, which results in dynamic T-SQL generation. Okay, it looks very similar to T-SQL, but it's not. It's entity SQL. But I can still get back objects. I can define my query in a string and just invoke create query and get back my objects. And now I've got a list of objects, a list of customer objects. No different than if I would have used link. So that's cool. But so I could have used link or entity SQL to get back objects that are tracked and so on. But one thing you can only do with entity SQL, like I was saying on the slides, is to use the entity client. This is the same entity SQL, but I'm not going to get back objects. This is a more lightweight scenario. In fact, if you look at the code, it looks very similar to good old conventional ADO.NET against a SQL connection and a SQL command, and you invoke execute reader to get back a reader. It looks just like that, right? But it's using the entity framework. So I'm starting an entity connection with a connection string that looks like an entity connection string. Opening the connection, setting up the command, associating the connection and the command text, just like you would with conventional ADO.NET. It supports parameters, right? We're going to do a parameter substitution there, just leave out the @ sign for whatever reason. Execute the reader. It's very strictly read forward. In fact, unlike a regular reader, well, even a regular reader, once you read a row, you can't go back. But within the current row, you can randomly access your columns. That is not true of an entity reader. Once you read a column, you can't read an earlier column even in the same row. But otherwise, it looks and feels very similar. And here I loaded this list up without using objects. And finally, on the async tab, it's really easy. They added this in Entity Framework 6. It's really easy to make your queries and your updates run asynchronously by leveraging the task parallel library and the async and await keywords. So here you see I'm just outputting some text before I perform my operations and after I perform my operations. When things run synchronously, you'll see the operations are sandwiched in between before and after. But when I run them asynchronously, you'll see that actually this will fire before the operations. And it's as simple as just adding async to your function and using the await keyword before calling the async version of save changes. So, there's like you have the regular save changes, well, they give you an async version. You have the regular to list, they give you an async version of that as well. So let's see that run. Before, and then this all ran synchronously, and then afterward I run the async version, let it run. You can see merely because the after appears before the work got done that it executed asynchronously. So there's more that I wish I could have gotten to, except I ran into those technical difficulties. I'd be happy to run this again at any time in the future, or maybe just do a 30-minute code first, demo, a presentation on code first as a follow-up to this. But with that, I thank you, and I hope you found it informative. If you didn't know anything about EF before, I hope you know quite a bit now, and even if you knew something before, hopefully you learned something new.